All right, in this video, we're going to cover two topics. One is basically messing around with powers or messing around with exponents and how we tidy them up. And then I'm going to introduce some of the basic rules or basic shortcuts for calculating derivatives, right? So why don't you pause, copy this down, and then I'll throw in a few little examples. All right, so as we go to calculate derivatives, simplifying them is going to become really important, and that's often going to involve the exponents, all right? So few basic facts about exponents you've learned before, but maybe you're a little rusty on. If we have a negative power, that means I could rewrite it as 1 over x to the positive power, right? So for example, x to the negative 5 can be thought of as 1 over x to the 5th. Okay? And if I have a negative power in the denominator, like 1 over x to the negative 2, I can think of that as x squared. I can bring it up. So if there's a negative power, it basically means it's got to go into the other part of the fraction than where it currently is. And then the power becomes positive. Right? If we've got radicals, square roots, cube roots, what have you, there's a way of writing them as a power, which will be really useful when we take derivatives. So the nth root of x to the m is the same as x to the m over n power. All right. And that is also the same as taking the nth root of x first and then raising it to the mth power. So, for example, if I have x to the 8/3, that means I have the cube root of x to the 8th. Okay? Or the cube root of x all to the 8th. All right? And if I have, like, let's say the 7th root of x, that's actually x to the first in there. So I can think of this as x to the 1/7 power. And this form is going to, it turns out, be really easy to calculate the derivative of. Okay. All right. Well, when I have x raised to 1 power times x raised to another power, I can combine them by adding the powers. So for example, x cubed times x squared should give me x to the 3 plus 2, which is x to the 5th. Right? And this should not be a surprise because x cubed is x times x times x. X squared is x times x. So it looks like I've got 5x's multiplied together, which is x to the 5th. Okay. Similarly, x raised to a power divided by x raised to another power, I can combine the powers to simplify it by subtraction. Right? So if I had x to the 5th over x squared, that should give me x to the 5 minus 2, or x cubed, okay? And hopefully that's believable because x to the 5th is x times x times x times x times x. X squared is x times x, so I cancel out one of the x's, 2 of the x's, leaving 3 of the x's behind, okay? All right, and then if I've got x raised to the a power, quantity to the b power, I can combine those two powers with multiplication. So if I had x cubed, and I squared it, I would have x to the 3 times 2 power, which is x to the 6th, which hopefully is also believable because x cubed squared is x cubed times x cubed. And if you like, that's x times x times x for x cubed, and then another x times x times x for the other x cubed, and that's 6x's multiplied together, x to the 6th. All right, and then special rule, x to the 0 is 1. Okay, that's going to be true as long as your x is not equal to 0. Because 0 raised to the 0 power is not defined. So all of these basically had to do with multiplication and division or just solo x's. If I've got powers of x being added or subtracted, there's not much I can do other than factor something to the front. So for example, if I had an x cubed plus or minus an x squared, about all I could do is to factor an x squared out in front. And if I drag x squared out of x cubed, that leaves 1x behind. X squared times x, 2 plus 1 would give me the power of 3. Plus or minus, if I drag an x squared out of an x squared, I have a 1 left behind. So about all I can do with adding or subtracting powers of x's is factor. Okay. All right, well, let's check these out with some bigger problems. So I got two things that I want to simplify here. So why don't you pause, copy these down, and then I'll start cranking away. All right, well, so the first one, In the numerator, I have two powers of x being added or subtracted, and I just said there's not much I can do there other than factor out. So it looks like I could factor out an x to the fourth from here. And that would leave behind a 3. And if I drag 4 of the 7 x's out, I have 3 of the x's left. Okay. And if I factor an x to the fourth out of 5x to the fourth, I think I'm just left with that -5 all over. I'm going to rewrite the square root of x to the 7 as x to the 7 over 2. Okay. All right. So there's step 1 of my factorization of my simplification. Sorry. Step 2, I think I'm going to isolate the x to the fourth over the x to the 7 over 2. And then I can think of this 3x cubed minus 5 as being divided by 1. So I'm just going to put those two x's right in conflict with one another, right? Because now I've got x raised to 1 power divided by x raised to another power. So the rules from the previous board said I can do 4 minus 7 halves as my new power, and then 3x cubed minus 5. Okay. All right. Now, 4 minus 7 halves, let me do some scratch work over here. 4 minus 7 halves. 4 is the same as 8 halves minus 7 halves, so that's 1 half. Okay, so I think I'm going to get x to the 1 half times 3x cubed minus 5. So that's how the first one would simplify. If you want to run the x to the 1 half back through, fine, but I think it's pretty good there. Right, so the second problem, I've got no adding or subtracting. It's all multiplication and division, which makes our simplification actually easier. So the first thing I'm going to do is combine the x to the 7 and the x to the -3. My rules tell me I can simply add those two powers when they're multiplied together. And I think I'll rewrite the cube root of x, remembering that's x to the first, as x to the 1/3. Okay. All right. Now 7 plus -3 is a positive 4. And I can think of the x to the fourth and the x to the 1/3 like that. They're 1 power of x divided by another. So the rule from the previous board said I can do 4 minus 3rd as my new power of 1x, right? Okay, so some scratch work. Let's figure out what 4 minus 1/3 is. For 4 over 1, so I'm going to multiply top and bottom by 3 to get a common denominator. So I think I have 12/3 minus 1/3, which is 11/3. Okay, so this becomes 8x to the 11/3. And if you really want to see it as a radical, the 3 in the denominator tells a cube root, and then it's an x to the 11th underneath the radical. So either of those two forms is perfect. All right, so let's go on and do some derivatives now. All right. So these are going to be some of the basic rules for taking derivatives that we're going to use for the rest of the semester. So before this, we were calculating derivatives by taking the limit as h approaches 0 of f of x plus h minus f of x all over h, and it was a very tedious process. So we are now introducing some shortcuts, some rules for differentiation. So why don't you pause, copy, play. All right, first off, so a notational reminder. If I say d over dx f of x, that means I'm telling you take the derivative of f of x. F of x in parentheses and a prime on the outside said, again, take the derivative of f of x, right? Okay, so for these rules, c is just going to be like a constant or a number. So like c is equal to 11 or something like that, just a number. So the first rule is the derivative of a constant is always 0, all right? No matter what the constant is, the derivative of a constant is 0. This should make some sense, but what it's saying is that the derivative of a constant like 17 is equal to 0. Now, if I give you the function f of x equals 17, that is a horizontal line at height 17. And the derivative is the slope of that horizontal line. The slope of a horizontal line is 0. So this rule hopefully makes sense from a graphical idea. A constant function is a horizontal line. A horizontal line has slope 0. The derivative is the slope of the graph. So this derivative is 0. All right, so that's called the constant rule. The power rule says if I have x raised to a power and I want to take its derivative, it's very simple. I'm going to take the power of n, drag it to the front, and then multiply it by x raised to the new power of n minus 1. So, for example, if I had the derivative of x to the 9th, n is being played by 9 here, so the rule says take 9, drag it down in front, and multiply by x, and the new power is going to be 1 less than the original, so 9 minus 1, which would then simplify to 9x to the 8th. Okay. All right. And it would also mean that if I have the derivative of the square root of x, we now know the square root of x. There's a hidden 2 and a hidden 1. So this is the derivative of x to the 1/2. So the rule would say, the derivative rule would say, we'll take your power, which is 1/2, drag it down in front, and then your new power is 1/2 minus 1. So that would be 1/2 x. A half minus 1 is negative a half. Right? And from what we learned on the last board, a negative power means x to the 1/2 should go down in the denominator. And if you like, you could write x to the 1/2 as the square root of x to the first. So the derivative of the square root of x turns out to be 1/2 x to the negative 1/2, which could then be simplified into either of these two forms. Okay. So if we're taking the derivative of x to the power, we have a nice rule to follow. It works for every power. Now, in particular, the derivative of x, well, this is a special case of the power rule. X is the same as x to the first. So power rules say take your power of 1, drag it down in front, and your new power of x is 1 minus 1, which is a 0. And we know that x to the 0 is equal to 1. So we have that the derivative of x is equal to 1. Now, that should also be believable. If I give you the graph of x, y equals x, that's a line of slope 1. And the derivative of x is the slope of its graph, which is 1. Okay. All right. So we've got constant rule, derivative of constant is always 0. We have the power rule, derivative of x to the n is n x to the n minus 1. And this, the derivative of x equaling 1, is a special case of the power rule. All right. 2 more rules. Well, the derivative of a constant times a function is easy to calculate because the constant, I can just drag it out in front and multiply it by the derivative of the function. For example, let's say I wanted the derivative of negative 3x to the 7th. Okay. Well, my constant is negative 3 and it's being multiplied by the function x to the 7th. So the constant multiple rule says I can drag the negative 3 out in front and multiply it by the derivative of x to the 7th. Now, x to the 7th is going to fit the power rule. So first off, there's my negative 3 just floating around. And the derivative of x to the 7th, the power rule says take your 7, drag it down in front, and multiply by x to the power of 1 less than what we started with. So 7 minus 1. And then I just clean up. Negative 3 times 7 is negative 21. 7 minus 1 is 6. So the derivative of negative 3x to the 7th is negative 21 times x to the 6th. All right. And then finally, if I'm taking the derivative of one function being added or subtracted to another function, f plus or minus g, I can instead just take the derivative of f, take the derivative of g, and then add or subtract the results. right, so I'll wheel us over a little bit over to here, where there's a bit more room. So let's say I wanted the derivative of x squared plus x plus 7. Yeah, let's throw in a minus sign, just for funsies. All right, well, the adding and the subtracting doesn't trouble me at all. What the sum and difference rule says I can do is I can take the derivative of x squared, the derivative of x, the derivative of 7. So I can take the derivative of each of those three pieces and then add or subtract as we had before, okay? All right, so let's just take these derivatives. The derivative of the constant 7, well, that's the constant rule. The derivative of any constant is 0. So I'd have a minus 0 to end this. The derivative of x, well, we covered that on the previous board as well. The derivative of x is 1. And then the last derivative is the derivative of x squared, and that follows the power rule. So the 2 comes down in front, and my new power of x is obtained by subtracting 1 from the original power. So I think that's x to the first. So if I simplify, I think I get 2x to the first plus 1, which we would more normally call 2x plus 1. So the derivative of x squared plus x minus 7 is 2x plus 1. Okay, we'll do a lot more of these in class.